Yeah.
All right, now x cubed plus 9x squared minus 27 equals, you do have to cube this x plus 3 cubed. So the most efficient way to do it is to use a formula if you had like a reference sheet for it. Otherwise, you got to FOIL and then multiply again. So this becomes x squared plus 6x plus 9 times x plus 3, like that. And then you have to multiply this. So you're multiplying that x by everything in here and that 3 by everything in here. X cubed plus 6x squared plus 9x. And I use like what's called a waterfall approach. So when I multiply by the 3, I line them up underneath so that the terms match.
Yeah.
Now I have unlimited space. And you should consider that too when you're working on problems. Like, don't try to fit things in. Think of it as flying, get open spaces to fly in. And bring the other side down. Okay. So this looks awful, but it can be solved. You end up getting a bunch of cancellations. The x cubed cancels because they're on the same. Whenever one's on each side, they cancel out as long as they're same sign. The 9x squared cancels out, and you're left with a nice linear equation here. Minus 27 equals 27x plus 27. The 27s do not cancel because they're opposite in sign. Okay. And so you subtract 27 from both sides, minus 54 equals 27x, x equals minus 2. Now there's a bit more to do here, but is everything clear up to this step?
Yep.
Okay, now you're really supposed to check your answer. You really are. And when I say check, not to go look in the back of the book or the answer key, you're supposed to go back and check, because when you do something like this, where you cube one side of the equation or square it or something like that, you're changing, like, for lack of a better word, the space of the problem. And you really want to make sure that that actually works in the original equation. Like, go back all the way to the original. It takes time to do that. So if you don't want to do that, I understand. I probably wouldn't have done it as a student, but now I know that could really matter. But this one, what answer did I give you? -2?
Yeah.
Yeah, the graph of this is really wild. It only has one solution, which is kind of interesting. Here, I'll snip that in. I'm big on graphing. I know you can't use that here, but it's kind of an interesting graph. You can see it just hits in the one spot there.
Huh. Interesting.
Yeah. So I would check your answers. The exams are where you're likely to see the exceptions, not on homeworks. Things like that. So okay, 6 down, 7. Do we need to do 7 since it's in the same sort of category?
No, I've already done
Okay.
it. I just wanted to double check my answer.
Do you want me to check the answer, give you the answer to 7?
Yeah, sure. That might be worthwhile.
Okay. I'm just going to snip it so I've got a reference point for it. So here one way to check, and this is not cheating, this is using like tools. So let me just throw this in the chat. You probably already know about this one, Desmos graphing. I love graphing stuff. I think it's really useful to see things visually. You can always graph a lot of these to verify your answer. You obviously don't have any show work when you're graphing, but it looks like it's 16. M is 16 is the answer.
Okay, that's
Do you agree? Do you agree, disagree? Okay.
Yeah.
All right. And so how I'm doing that graphically, I'll just snip this in real quick, is I'm graphing it. I mean, there's lots of tools out there to verify your answer, but this is a useful one. You just see that it hits at 0. There it is.
Interesting. All right.
All right.
Well,
So
that's helpful. Okay. All right then. Yeah, I did get that right too. All right.
Good.
let's see, 8. This was the one just introduced in this lesson, so that might be worthwhile to go over.
Okay. All right, so we've got a system of 3 equations, an x, y, and z, and you have a lot of options when you solve systems. You probably learned graphing.
Mhm.
And in this one, you wouldn't necessarily know what a graph of 3 dimensions is, but it's a plane, not an airplane, but like a sheet that extends infinitely in every direction.
Mhm.
But they don't usually talk about that. But the other option you learned was substitution, and then you learned elimination, and you may have even done some like matrices or determinants, a few other things there. They're all actually allowed, but my guess is you use some variation on substitution to solve these today. Does that sound right?
Yeah.
Okay. Now what's really important here, because it looks overwhelming at first, the third equation only has 2 variables in it, which is really good news.
Mhm.
Okay, because you can solve for one of the variables. And I'm going to choose arbitrarily to solve for z, but I do have a reason. It really isn't arbitrary. Z is easier to solve for than y in this last
Yeah.
one. Okay.
Yeah.
Now, when I do that, I take a look and I notice that I'm going to put in minus 2y wherever there's a z in the first 2 equations. And that's good news because that means the equations will be reduced by 1 variable. So instead of z, it's going to be minus 2y equals 7. That's the first equation.
Mhm.
And the second one is x minus 2y plus minus 2y equals minus 2. I tend to always substitute in parentheses, especially if the number is negative and especially if there's a subtraction operator in front. I would encourage you to do that as well. It will avoid sign errors down the road.
Mhm. Gotcha.
First equation becomes 2x plus 3y equals 7. And the second equation becomes x minus 4y equals minus 2.
Mhm.
Any questions on that?
No.
Good. So the point of what we did, the whole emphasis is that you now have it in a form that you know how to solve. Like you're supposed to be an expert at solving
Yeah.
systems of equations. So like everything I just mentioned was in play. Graphing, substitution, elimination. Does anything stand out to you when you see this?
No, it's all relatively familiar.
Like, but do you have a favorite method?
Oh, so in this, I would probably use, yeah, substitution.
Okay, so if you're going to use substitution, you're probably going to substitute or solve the second equation for x. Does that
Yeah.
sound right?
Yeah.
So I'm going to suggest we use elimination, even though I know you said it. And the reason is because
Mhm.
substituting in more than just a simple expression can just add more time to it. Again, this is just Matthew's preference.
Yeah.
It doesn't mean that you're wrong or I'm right. Just it's a preference. Okay.
Yeah.
Okay, and then from here, I'm going to add the equations. 11y equals 11. So y equals 1. Okay. Are we done?
We got to solve for X
And z.
and Z still. Yeah.
Yeah. So unfortunately, we're not even close to done. We're going to use that second equation, x minus 4y equals minus 2, because it's the most simple one for getting x, in my opinion. And so we got x minus 4 equals minus 2, x equals 2. Now you're in really good shape. You can go back and find that z was minus 2y, minus 2 times 1, which is minus 2. So they sometimes call it an ordered triplet.
Mhm.
Always found that a little awkward, but nevertheless, it's 3 points, x, y, and z. Usually they want this.
Yeah.
So now someone that flies, you understand 3-dimensional space probably a little bit more than
Yeah.
others. It's a little bit odd when you're in the air. We don't,
Indeed.
yeah.
Let's see. All right. I'm just taking some notes right now. All right. That's very helpful. Thank you.
Do you have an interest in going into the military and maybe doing something with flying in that
Mm,
direction?
Well, if you would have asked me 2 years ago, the answer would have been yes, or even a year ago. But I don't know. Not really anymore. Just
So so I'll just say
yeah.
like the people that fly, you probably already know this, they have to be really good at math, really good at
Yeah.
math and physics and all that. It's not because that's required to fly, as you probably figured out. It's just it's a differentiator. And but
Yeah.
you're on a good track. I mean, you seem to understand the stuff we're talking about, and it's just more and more of the same.
Yeah. Yeah,
Um,
definitely.
so
Yeah.
so nine, are we gonna do nine because it's the also in the section?
Yeah, sure. That'd be helpful.
Okay. Nine is in some ways easier than eight, because it's, if you look at that third equation, I'm just getting it snipped in here, it's already solved for z. It's already sort of like standing out that, hey, you should do something with that. You
Mhm.
should take this and put it in for z and for z. It's you don't have to solve anything. What the approach we just use only really works because that last equation can be solved for one of the variables, one of the other variables. On a test or quiz, it might be that it's y equals 3z, and then you'd put that in for y.
Yeah.
It's not always z. Okay. But
Yeah.
for us, it's x plus y plus 2y equals 7. 2x minus y minus 2y equals minus 4.
Mhm.
What am I doing here? I don't mean to do that. Sorry. Lost my mind. Okay, we're going to combine like terms x plus 3y equals 7. And then the second equation, combine like terms 2x minus 3y equals minus 4. What do you see here when you look at this to be able to solve it?
Um, so then I'd probably change the first equation and do substitution to x equals minus 3y plus 7.
But these are already in opposite
Oh,
signs.
right. So we could do elimination
You can
then.
just add them together.
Yeah.
Path of least resistance.
So 3x equals 3.
So
So
x is
x equals
1.
1.
Yeah. Go ahead and solve for the other variables for me, y and z, and let me know what you come up with.
Okay. Let's see. All right. Sorry. Just give me a second. I'm just going to finish the first one. All right. Okay. All right. Uh, it's gonna be good. Let's see. Sorry, I'm just copying it down first.
Let me know if I need to scroll up and get caught up here.
All right. Okay, so I'll go for y first. Okay. Hmm. Let's see. Oh dear, my pencil's falling apart. Dog started chewing on it. Gotta get me a new one. Let's see.
Are you caught up though here? I mean, you agree that X is 1, that's,
Yeah,
okay,
yeah.
okay.
There's no issue right there.
Okay, so I mean, I suggest using, I'll just highlight it here, the one where there's, more pluses and less subtraction. I'd probably use this one for Y. And then Z is already solved for, it's 2 times Y. So once
Oh,
you get,
gotcha.
once
Okay.
you get Y, you're gonna have Z. You almost always go back to the two equations and 2 unknowns to find the other variable.
Gotcha. All right. So Y is going to be 2.
Okay, great.
Let's see. And then, oops. My siblings have been stealing all my pencils. They had like a collection of 30 in a jar, and now they're all gone. All right, let's see. Oh, Z. All right, my solve for Z now. Z equals 4.
Yes. So you'd want to present your answer as 1, 2, 4. Now, if you had unlimited time, you would try this in each of the original equations and make sure that it still worked.
Yep.
It's rare that you would get such nice numbers they wouldn't work, but I mean, it's possible.
Mhm.
So that looks good to me. Where should we go from here?
Okay. Let's see. I kind of already did that last time. The way these math lessons work is typically the first 5 or so questions will be the most time consuming. Then sort of the middle 15-ish will be new ones, but they don't usually take that long. And the last 5 or so will be pretty long as well. So
Yeah. Well, again, I'm happy to help you work through these to save you time and maybe
yeah,
give you some hints. Like if you're just like, hey, Matthew, we got to work through 1 through 5. Like it doesn't matter to me. You're the customer. You tell me what you
gotcha.
want to do. I mean, it's
Okay.
not like we're flying and there's danger here. We're just going to do as many problems as we can get done.
Okay.
So you got to just tell me where you want to go.
Yeah. We kind of did this last time, but 10 would be quite helpful.
Okay. So 10 is another special triangle, and it really helps to have the reference triangle that goes with it. Let me actually send you a link to a couple of reference sheets on my website. This one's for 30, 60, 90. I'm going to draw it, but it might help you. Yeah, just throw this on here in case you want to look at it later. Okay, so the main thing here is to know how to draw the reference triangle on a 30, 60, 90. So you start with the 30 degree, and I'm drawing the 30 degree in the same place that your 30 degree would be, and the short leg is called X. And the hypotenuse is always double X. Okay, so your short leg doubled is the hypotenuse, and then the long leg is X root 3. This is the long leg. And what you do is you set the known side equal to the reference side. So your known side is 8, and that's the hypotenuse. Do you see that? Yes, no, maybe.
Yes.
Okay, so you set 8 equal to 2x. And you find x. You say, okay, well, x is 4, but x is the reference side. Like it's referring to the short leg over here, which is 4. Okay, meaning your short leg is 4. The short leg is always half the hypotenuse.
Okay.
I feel like you either don't understand, never seen this before, tired, I don't know, something.
Let's see. Gotcha. Okay, so is this just on a 30, 60, 90?
Yes.
Okay, gotcha. I was
But
wondering because, usually it's a squared plus b squared equals c squared, so that makes sense.
that does apply, but this is a shortcut for that. And the other one is a
Mhm.
45, 45, 90 that you might need.
Mhm.
So that's another thing here. But in terms of finding R, you can't think of it as R. You have to think of it as the long leg. The long leg is the short leg, x times root 3. The short leg times the square root of 3.
Mhm.
You almost want to think of it as words instead of equations.
Okay. Let's see. Okay, so if x equals 4, then just 4 times the square root of 3, I guess, would be r.
Yes. Yes.
Okay.
Yes.
Let's see. All right, let me copy that down. R. All right. All right. Let's see. Okay, so then I guess, is there anything else? I think that's it for that one, right?
Yeah.
All right, so then, um, let's see. We can do, I guess, question number 12.
Sure.
So I was leaving gaps in the paper for the rest of it. All right, so this is similar to what we did last week, -2r, -7u in polar form.
Yeah. So from the origin, okay, let me get this in the right spot. Okay. So -2r means instead of going right, you're going left 2.
Mhm.
And instead of going up 7, you're going down 7.
Yeah.
Okay. And I mentioned this, there's what's called the reference bow tie. I don't know if you've gone to any formal dances or anything like that at school, but the reference bow tie is the triangle you draw based on the quadrant you're in. So in the quadrant here, this is our triangle that we're drawing because we're in the third quadrant with this. This is 2 and this is 7. Is that okay? Is that clear so far?
Yes.
Okay. So we need to find the hypotenuse. Actually, these are negatives, but we need to find the hypotenuse. So that's the a squared plus b squared equals c squared.
Mhm.
Square rooted. So you have to square 2, which is 4, square 7, which is 49. It's the square root of 53 here.
Yep.
And so that's your like, if you think of it's r comma theta is your polar form, that what that means is your r is square root of 53.
Yeah.
The angle is started from the origin positive and you go back counterclockwise this direction. That's your angle.
Okay.
Okay, so it's good. We're gonna have to do this in pieces because the triangle only gives you, like, if we found, let's just call that x for your angle there. It's just gonna give you that little bit in there. We have to add 180 to it.
Yeah.
Okay, so how do you find x? Well, you use one of the trig functions. Tangent's a good one. Tangent of x equals y over x, or opposite over adjacent. Okay. So if you have a calculator handy, make sure your mode is in degrees. Could you solve that for x?
Yep. There we go. Let's see. All right. So I guess that would be on Desmos. Let's see. All right. 74 degrees.
Ish, yes, right in there. So x is 74 degrees. Calculator doesn't know that you're in the third quadrant. It doesn't know anything. It just knows that it's 74 degrees. You have to then add the 180 because you know you're in the third quadrant.
Yeah.
So your answer is square root of 53, comma, 254 degrees. But that's only one of 4 answers. That's probably the most direct one. There's actually a few other ways to get there, but
Okay.
We can leave it at that for now.
All right. Very well. That's helpful. Let's see. All right. It's kind of an old question, but I'd like to go over it anyways. 28.
Sure.
So let's see. Find the equation of the line that passes through -2, 4, and is perpendicular to 5x plus 4y equals 3.
Give me just a moment to grab the snip of this.
Good.
Okay, so find the equation of the line that passes through this point and is perpendicular to the equation. So the thing is, you got to get the slope of this equation. How do you find the slope of this equation? What's something you can do to get the slope?
Well, I guess we could graph it out and then compare x over y. So I guess this would be
I wish I had like a big, like, if you ever seen Family Feud, they got that X, ding. It's like, nope, we're not gonna graph it. We don't want to do that. That's not gonna work.
gotcha.
Good try. Good try. Graphing is very helpful. You should graph things you like don't know what they look like, and this looks like a line. It's that or whatever. But
Yeah.
so there's a better way. This is in standard form. Not that that really matters, but you need this to be in slope-intercept form.
Mhm.
Slope-intercept form is y equals mx plus b,
Yeah.
and that means you're going to solve for y.
Okay.
So go ahead and solve that for y. Let me know what you come up with, please.
All right. Let's go. Okay, so I got y equals negative 5/4x plus 3/4
Good. Okay, so what is the slope of the equation now?
minus 5/4 or
Very
negative
good.
5/4.
Good. So we want the perpendicular slope to this. So last time we talked about this a couple of ways. I don't know if any of those resonated with you, but it's opposite reciprocal or flip negate. You need the perpendicular slope.
Mm-hmm.
And so this is the perpendicular slope.
Gotcha.
Flip it, negate it. I also mentioned that the product of the two slopes is -1. But once you get the slope, you throw away everything else that you just did. Like none of that is useful.
Mm-hmm.
I'm not sure I'd literally cross it on a test, but it's not needed anymore.
Gotcha.
Now there's two things that you have a point and a slope, and there's three forms of an equation. There is one that uses point and slope. It's called point slope form. Do you remember that one from last time?
Yeah, I remember you talking about it.
Okay. So here's the form. You might like, if you go out and look for like a college algebra or pre-calculus reference sheet, you want to have all these forms just available so you can look them up quickly. It requires a point, that's the x1 and the y1, requires a slope, which you have. So you're basically done. Your point is -2, 4. You substitute in for the values that you know, and then you're done. You have it.
Okay. All right. Usually has us put it in a different form. So it would be like in a y equals mx plus b format.
So remember, it doesn't tell you that it has to be in that format.
Yeah. Yeah.
Now, if you want it in that format, you have to solve for y, or you have to go back and use the y equals mx plus b. We can do that if you would like. So let's say you're like, hey, Matthew, I really want to use y equals mx plus b. I'm like, okay, y equals 4/5 x plus b. Use that point, -2, 4. And you're using that point for x and y. So 4 equals 4/5 times -2 plus b.
Okay. Yeah, she wants to make sure it's in that form specifically, so
Okay,
let's see.
so you treat -2 as -2/1. Okay.
Mhm.
Now this will save you a little bit of time. When you recognize that your denominator on the right is different than the denominator on the left, you really want to change the one on the left to match it. So you really want to make this into 20 over 5.
Yep.
Because when you add 8/5, you're going to get 28/5 equals b, and you really want to not be messing around with fractions if you can. That goes back into this line right here.
Mhm.
Always substitute back y equals 4/5 x plus 28/5.
Yep.
Now, in terms of a check, like if you wanted to go to Desmos and you graph this and then you check that that point's on the line, you could even graph the original line and you'd see that they're perpendicular to each other. That would be cool. If you had time, that would be great to do. But there is no unlimited time.
Gotcha. All right. Let's see. Okay. Well, if you have some spare time. This doesn't look too bad. Might as well go over. Let's see. Can we do question number 20?
Yep.
Okay.
Get that snipped in. Here we go. Yeah, so you said 20. Sorry about that. Okay, solve by completing the square. Ooh, boy, they've not done you any favors here. I'm going to start out just rewriting this a little bit. I'm going to move the I'm going to move everything all to one side just to illustrate how I like to complete the square.
All right.
So is that, if this is okay?
Mhm.
So what some people teach is to eliminate this 2 by dividing it. I'm not going to do that. So if you don't like this approach, you can just never use it again. But this is me trying to help you. So you next factor out this 2. This is where it gets a little wonky because it's fractions. But this is the form you're supposed to be really comfortable with in terms of completing the square. Like you're supposed to be like, oh, I take half of 7/2 and I put it in parentheses and then I square. Like you're supposed to be really, now if it was like 8x, you'd be like, great. But because it's 7/2, we're like, oh, it's really hard. And it is, it's uncomfortable. But half of 7/2 is 7/4. Okay. So it's not impossible. It's awkward. Okay. Now you square to go back to this previous line. You square this one right here. So that's 49 over 16.
Yep.
Is that okay?
Yeah.
Now to go back to the previous line, you multiply everything by 2, including that last term. So this becomes 49 over 8. And I draw these like little placeholders to indicate that it's the same thing on both sides.
Let's see.
So let me know when you get caught up here because there's a few more little wrinkles. They didn't give you a nice one here. They gave you kind of a level 3
Yeah.
one to try here.
Let's see. Hear the dog barking?
No.
All right,
I had
good.
a dog barking at me the last lesson. I've never known how that's possible. They can detect me through the Zoom.
Wow. Strange.
All right,
Let's see.
you got to bring this 2 down. That's kind of another thing that sometimes gets forgotten. And then on the right, you got to make this -8 over 8 plus 49 over 8. So it's 41 over 8.
Mm-hmm. Yep.
Okay, then you got to clear this by multiplying by 1/2 or dividing by 2. So you get x plus 7/4 squared equals 41/16.
Mhm.
And again, all this is being done because you said you must complete the square.
Yeah.
It's like walking instead of driving. It's like, why would I ever do that? But because they tell you to do it, you do it. So now you take a square root of both sides, plus or minus. So it's x plus 7/4 equals plus or minus the square root of 41/16. And you're supposed to realize that you can reduce the square root. It's the square root of the top and bottom. Square root of 41 is unknown. The square root of 16 though is 4. So you can
Yeah.
do a little bit there. And then you will move the 7/4 over. So you subtract 7/4 from both sides. X equals minus 7/4 plus or minus square root of 41/4.
Gotcha. All right, good. I got the same answer. I was going along as we were going. Great.
Great.
Okay. Let's see, nothing that I can see that. All right, let's do 26.
Okay. Okay, so you've probably seen this before. Anything with the 0 power is 1, but it's just the thing that's being taken to the 0 power is 1. So the first one's not on top left here. This truly is minus 3 to the power of 0, and that's just 1. Okay, but the one to the right of it, you really have to treat it like this: -1 times 3 to the 0.
Yeah.
Okay, so the 3 to the 0 is 1, but not minus 3 to the 0. Minus 3 to the 0 is 1, so this becomes 1 times -1.
Mhm.
Now, similarly on the bottom, it's -1 times 9 to the minus 3/2.
Okay.
And that's important to break apart because you can see there you're going to get a cancellation. Okay, so
Gotcha.
now the negatives cancel. Great. This exponent, when it's negative, you can flip between the top and the bottom. So because it's negative on the bottom, it becomes positive on the top.
Okay.
And then now it's a much more standard problem. Okay, you rewrite 9 as 3 squared to the 3/2 power. And then when you have an exponent to an exponent, you multiply. So you're taking 2/1 times 3/2, which ends up being 3 to the power of 3. So these are the exponents that turn into that 3 right there. And then you just get 27.
All right. Sounds good. Okay. Let's see. Anything else? That's everything that I can think of. Yeah.
Okay, we can certainly stop here.
Yeah.
All
Thanks
right.
so much.
Yeah, so